Hello everyone, welcome again. So in this video we are going to start harmonic mean, and previously we have completed all the other chapters regarding geometric mean, arithmetic mean, median, mode and stuffs like that. So let us start about the new harmonic mean here. And this is similar to the previous chapters actually, because as you can understand, harmonic mean is just the reciprocal of arithmetic mean. It's not really the reciprocal, but given as data set. So let me just do it. Given a data set x1, x2 all the way up to xn, we call the aim, that is the arithmetic mean, as the aim can be defined as follows. It's just the average of this numbers whole divided by n. Now consider the same data set but with reciprocals. Consider a data set x1 inverse, x2 inverse, and all the way up to xn inverse. So if there is a data set which has the same exact data points with reciprocals of them, then aim of this data set, so let's call this mu1, and let's call the arithmetic mean of this data set as mu2, which would be x1 inverse plus x2 inverse plus dot 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 x1 inverse, right? Xn inverse divided by n. Then if this data set were to be called as S, then the harmonic mean, then the harmonic mean of S is given by hm equals to mu2 inverse, or in other words 1 divided by 1 by n summation of I equals to 1 to n 1 by xi. A more prettier form to write this would then be n divided by 1 by x1 plus 1 by x2 plus all the way up to 1 by xn. So the harmonic mean of a dataset consisting of points x1, x2 up to xn can be just written as n by 1 by x1 plus 1 by x2 all the way up to xn, and that is how the harmonic mean is defined. And even if you have weights, so there is another case where you have the weighted harmonic mean. So if xi has weight wi, then, which is basically the frequency, then the harmonic mean is defined as summation I equals to 1 to n wi divided by summation I equals to 1 to n wi by xi. So this is the weighted harmonic mean. This is the weighted harmonic mean. Correct? So harmonic mean is basically very easy to understand once you get the hang of it, and it's not really that much of an issue when you have already completed stuffs like arithmetic mean and geometric mean. So it won't be that much of a problem in solving this kind of example. So we are going to solve some 2-3 examples to understand how the harmonic mean works. But before that, there's an important relation that we must understand, and we just need to remember it. No proof would be provided because the proof would be out of scope right now because of the heavy amount of calculus included. It's an important relation, or rather an important inequality states that the arithmetic mean is greater than or equal to the geometric mean and is greater than or equal to the harmonic mean for the same data set, right? So this is the important inequality, that the arithmetic mean is always the greatest among the means. The geometric mean is greater than the harmonic mean, but it's always lesser than or equal to the arithmetic mean, and the harmonic mean is the least among all the means. And it's very important to understand this relation. Now, let us come to a few problems here, which we shall discuss. Problem 1. Okay. A cyclist pedals from his house to his friends at 10 km per hour. Okay. He goes back with 15 km per hour. Find the average speed. We are going to find the average speed. So this is an example of a harmonic mean. Although the term used here is average, it necessarily means it doesn't necessarily mean that we always need to look for the average, because the average can be tricky. You do not really add the speeds and divide them by 2. That's not how it works. Okay, so whenever we say average speed, it means total distance divided by total time, and not the other way around. Okay, so we need to be sure. So let's say, first let me write the solution here. Let's say this is the cyclist here at this point. Okay, this is his friend's house, and he goes from here to here. He goes at a speed of 10 km per hours, and when he returns, he comes at a speed of 15 km per hour. Let us consider that this distance he covers is given by x kilometers. Okay, we know average speed is equals to total distance by total time, right? So what is the total distance he covers? So total distance that he covers according to our assumptions is x plus x, which is 2x, right? Because he goes to the friend's house covering a distance of x, and he comes back covering a distance of 2, another x, so it makes a total distance of 2x. Now what is the total time taken? The total time taken for the first journey, the time is specifically distance by speed, which is x by 10, and for the second part of the journey the time taken was x by 15, and this would give us x multiplied by 1 by 10 plus 1 by 15. Okay, therefore since we have the values, we can write average speed is equals to total distance, which is 2x, divided by x multiplied by 1 by 10 plus 1 by 15, and this should give me, after cancelling the x, as 2 by 1 by 10 plus 1 by 15. And you can see this is basically the harmonic mean of 10 and 15, right? Because we have n by 1 by x1 plus 1 by x2. So whenever we have a problem where we are going to find the average speed uh, over multiple durations, over multiple stoppages, where the cyclist goes to one place and then goes to another place, but the distances are equal, but using different speeds, the average speed over all durations can be found out using the harmonic mean of the speeds. And this would give you 12 basically as your answer. So 12 kilometer per hour is basically the average speed of his entire journey. And if you can notice, it is not equals to 10 plus 15 divided by 2, which rather is 12.5. So see, there's a minor difference, right? So from this we can conclude a more general statement that if equal distance is covered with speeds v1 v2 all the way to vn, then the average speed is harmonic mean of the dataset vi. That is, the average speed would simply be n by 1 by v1 plus 1 by v2 plus all the way up to 1 by vn. Okay, and this would give you n by summation of I equals to 1 to n vi. And even if there are different speeds, so if the distances are different, if the distances are s1, s2 all the way up to sn, then this is a case of weighted harmonic mean. Then average speed, as you can see how harmonic mean directly gives you the answer here. It's a weighted harmonic mean with weights s1, s2, sn. So I equals to 1 to n si divided by I equals to 1 to n si by vi. This is the answer. So the harmonic mean is very much useful in a lot of cases, including this one, and we very much understand the value of it right now. So let us see if we can do one more problem. Let's see. So let's say we have two groups. Let's say we have two groups. We have two data sets. X1, X2 all the way up to Xn, and Y1, Y2 all the way up to Yn. H1 and H2 are harmonic means of the data sets. Find the combined HM. So this is another typical problem, and we have encountered problems like this before as well. So first we need to understand what H1 and H2 are. So H1 is defined as n by summation of I equals to 1 to n xi, right? Similarly, H2 can be defined as n by summation of I equals to 1 to n yi. Now let us see what we can do. The combined data set is let's call this S omega, and the data set is x1 comma x2 comma x3 all the way up to xn comma y1 comma y2 and all the way up to yn, and there are a total of 2n elements here, right? The harmonic mean of this one would be 2n divided by I equals to 1 to n 1 by xi plus I equals to 1 to n 1 by yi, right? Now we recall that h1 was basically equals to n by I equals to 1 to n 1 by xi, right? So this would mean that I equals to 1 to n 1 by xi summation of I equals to 1 to n should be equals to n by h1. Similarly, I equals to 1 to n 1 by yi should be equals to n by h2, and using this we have capital H equals to 2n by, so we have this summations, right? So we have n by h1 plus n by h2, and then cut off and we simply get 2 by 1 by h1 plus 1 by h2, which is basically the harmonic mean of the two harmonic means. So we get a more general result now, that if h1 comma h2 all the way up to hk are k harmonic means of equal size, then the combined harmonic mean for the data set is capital H equals to k divided by I equals to 1 to k 1 by hi, and this should complete our final result. So this would complete our result, and this would complete our section of harmonic mean as well. And from the next section onwards we shall move on forward to dispersion and methods of dispersion, which is a very huge topic to cover, and we shall cover it very soon. So that's it, which I shall see you in the next video.